Hello guys, welcome on Tesla Eduventures. In this video, we are going to discuss the concept illustration problems which are generally asked in JEE and other exams from calorimetry. So these are called as ice water problems, and later on in the next video I would be bringing some miscellaneous mixed problems based on ice water and more other concepts. So basically this video is all about the ice water problems. So first of all, in this first question you can see that there is 10 gram of ice at minus 10 degrees Celsius, and we have to convert this ice into 110 degrees Celsius steam. So we have to find out the amount of heat required for that conversion. So we know that to convert ice at minus 10 degrees Celsius, we should convert it into 0 degrees Celsius ice first of all, and then that 0 degrees Celsius ice must be converted into 0 degrees Celsius water, and then that 0 degrees Celsius water must be converted into 100 degrees Celsius water, and then that 100 degrees Celsius water must be converted into 100 degree Celsius steam, and then that 100 degrees Celsius steam must be converted into 110 degrees Celsius steam. So there are total 5 conversions. So let us suppose that heat required in the first conversion is Q1, in the second one it is Q2, in the third one it is Q3, in the fourth one it is Q4, and in the fifth one it is Q5. So Q1 will be equal to, you can see that in the conversion of ice at minus 10 degrees Celsius to 0 degrees Celsius, temperature is changing, and when temperature changes, the heat exchanged is ms delta T. So M is 10 grams, so this is Q1 would be ms delta T, so it is ms delta T. M is 10. Now you know that the specific heat of ice is half and delta T is 10, so it is equal to 50 calorie. This is in calorie per gram degree Celsius. And Q2 is the heat required to in this conversion. So you can see in this conversion the phase is converting from solid to liquid, so the heat involved would be m into latent heat of fusion, and mass is 10 grams and latent heat of fusion is 80, so it would be 800 calorie. Now in Q3 you can see that water is being converted, the temperature of water is being raised to 100 degrees Celsius from 0 degrees Celsius. So the heat involved would be ms delta T. Now m again would be 10, s would be 1, and delta T would be 100. So it is equal to 1000 calorie. And Q4 is the heat involved in this conversion. In this conversion, the water at 100 degrees Celsius is being converted into steam at 100 degrees Celsius. Again, the phase is being converted, so the heat involved would be m into latent heat of vaporization. So it is equal to 10 into latent heat of vaporization is 540, and therefore it would be 5400 calorie. And Q5 will be the conversion of 100 degrees Celsius steam into 110 degrees Celsius steam, which is the raising the temperature of the steam. So it would be ms delta T again, and m is 10, s is half, delta T is 10, so it would be 50. So the total heat would be the sum of all these heats, and I think it would be, this is 100, this is 900 and 1900 plus 5400 would be equal to 7300 calorie. So this heat would be required for raising the temperature of minus 10 degrees Celsius ice into 110 degrees Celsius steam. Now let's move on the second problem. In this second problem, you can see that there is 10 gram of ice. This is 10 gram of ice at minus 10 degrees Celsius, and it is being mixed with 10 gram of water. This is 10 gram of water at 10 degrees Celsius. So we have to find out the final composition and the temperature of the mixture. So what we do, that let us assume, assuming that finally all water is formed at 0 degrees Celsius. We are assuming that finally all water is formed at 0 degrees Celsius. So ice would be coming from minus 10 degrees Celsius to 0 degrees Celsius water, and water would be coming from 10 degrees Celsius to 0 degrees Celsius water. And in this process, the heat absorbed by the ice would be equal to ms delta T for the change in temperature of ice from minus 10 degrees Celsius to 0 degrees Celsius, plus it would be m into L for change of phase of ice from phase of ice at 0 degrees Celsius. So it would be equal to this is m is 10 gram and delta T is 10 again, and S is half, so it would be 50, plus m into LF would be equal to 800. So there would be 850 calorie of heat required by the ice, and heat released by water would be ms dt, ms delta T. So you can see that the mass of water is 10 grams, specific heat is 1, and S is delta T is 10. So this is 100. So you can easily see that it is not possible that all water would be formed, because the heat required by the ice to completely melt is 850, and water can only supply the heat which is equivalent to 100 calories. So it is not possible for water to completely melt the ice, but you can see that water can bring the ice from minus 10 degrees Celsius to 0 degrees Celsius, because for that process ice requires only 50 calorie and water can give 100 calorie, which means that 100 minus 50 is the remaining heat, and that remaining heat is utilized in partially melting the ice. So we can say that 100, which is the heat given by the water, minus 50, which is the heat required by the ice to travel from minus 10 degrees Celsius to 0 degrees Celsius, is the net heat remaining, and this net heat would be utilized in partially melting the ice. So let's suppose that m is the mass of ice melted, this is melted ice, into L, latent heat of fusion. So m melted will be equal to 50 upon latent heat of fusion is 80, so it would be 5 by 8 grams, and therefore we can say that the composition has 10 minus 5 by 8 grams of ice and 10 plus 5 by 8 grams of water, and as you can see that they both are coexisting, therefore the tea mixture, final temperature of the mixture would be 0 degree Celsius. Now let's move on the next question. In this question, you can see that again there is 10 gram of ice at minus 10 degrees Celsius. It is mixed with 2 grams of water at 10 degrees Celsius. So step 1 is obviously to assume that all water is formed. Assume that all water is formed at 0 degrees Celsius. Okay. So ice will travel from minus 10 degrees Celsius to 0 degrees Celsius water, and water will travel from 10 degrees Celsius to 0 degrees Celsius water. So the heat absorbed by the ice, and this is the heat released by the water. So heat absorbed by the ice would be again same, because in the previous question the data was same. So you can see that 10 gram of ice was at minus 10 degrees Celsius. So we can directly use that data. So it was, I think, 850 calories, and the Q released would be different, because in this case the mass of water taken is different. So it would be ms delta T. So 2 into S is 1 and delta T is 10. So it is only 20 calorie. So you can see that the heat required by the ice to travel from minus 10 degrees Celsius to 0 degrees Celsius ice form, solid form, was 50, and the heat required by the ice to completely melt was 800. So in this way the total heat was 850. But you can see that water, the heat released by the water is not enough to bring the ice to 50 degrees Celsius also. In fact 0 degrees Celsius also, because to bring the ice to 0 degrees Celsius it is required that water should at least give a heat of heat which is greater than 50 calories. Okay, so what I am trying to say, that this heat released by the water is not sufficient to bring the ice to 0 degree Celsius. Now it doesn't mean that ice will not come at 0 degrees Celsius, but now what happens, that step 1 fails. So we can write that step 1 fails. Step 1 fails. Now what was the step 1? So step 1 was the fact that finally all the water was formed at 0 degrees Celsius. So now we can conclude that this is not the case in this one. Now what we have to do, that we have to execute the step 2. Now you can see that step 2, in the step 2 we have to assume that finally all ice is formed at 0 degrees Celsius. We are assuming that all ice is formed at 0 degrees Celsius. So when all ice is formed, then ice is coming from minus 10 degrees Celsius to 0 degrees Celsius ice, and water is coming from 10 degrees Celsius to 0 degrees Celsius ice. So the heat absorbed by the ice is only 50 calorie, and the heat released by the water is, you can see that it is this is ms delta T plus ml. So m of water was 2 grams, so 2 into 1 into 10 plus 2 into 80. So you can see that this is 180 calorie. So easily you can predict that this heat is greater than the heat required by the ice to come to 0 degrees Celsius. So water is giving some extra heat. So that extra heat would not be required by the ice, because we know that that ice is coming at 0 degrees Celsius and it requires only 50 calorie. So what would happen that water would come from 10 degrees Celsius to 0 degrees Celsius, and it would release 20 calorie heat, and remaining 30 calorie required by the ice would be released by the water by partially freezing. So we can say that the water freezes partially, and the complete some amount of water is left in the mixture, and some amount of ice is left in the mixture. So what amount of water freezes? So m of water freezes will be into L of fusion will be equal to, this is 50 minus 20, because ice required 50 calorie to come to 0 degree Celsius, and water gave only 20 calorie by coming to 0 degree Celsius, and remaining 30 calorie would be provided by the water by partially freezing. So this is 30. So m of water freezes would be 3 by 8, because latent heat of fusion is 80. So 3 by 8 grams of water will freeze, and hence we can say that therefore finally both ice and water coexist in equilibrium. Therefore T final will be 0 degree Celsius, and composition of ice, the composition of ice would be ice would be 10. In fact, initially ice was 10 grams, so it would be 10 gram plus the amount of water that has freezed is 3 by 8 grams. So this is 3 upon 8 grams, and the water would be 2 minus 3 by 8 grams. So this is the final composition, and this is the final temperature. Now what happens if we change the scenario by a certain amount? Let us see this scenario. You can see that I have changed the amount of ice, and I have changed the amount of water also. So assuming step 1, so we already know that with reference to the previous two problems, we can see that the step 1 will fail obviously, but as a new problem we should always check that let finally all water is formed at 0 degrees Celsius. So ice will be coming from minus 10 degrees Celsius to 0 degrees Celsius water, and water will be coming from 10 degrees Celsius to 0 degrees Celsius. Okay, so the heat absorbed by the ice would be 20 into half into 10 plus heat required to completely melt would be 20 into 80. So this would be 100 plus 1600, 1700. Okay, so this is 1700 calorie, and the heat released by the water would be m, which is 1, s, which is also 1, and delta T is also 10, so it is equal to 10 calorie. So by any chance water cannot bring this ice even to 0 degrees Celsius, because to come to 0 degrees Celsius ice requires 100 calorie of heat, and water can only give 10 calories of heat. So step 1 fails. So step 1 fails. Now let us execute the step 2. Step 2 says that assume all ice is formed at 0 degrees Celsius. So we are assuming that all the amount of ice is formed at 0 degrees Celsius, and in this case you can see that ice will come from minus 10 degrees Celsius to 0 degrees Celsius, ice only, and water will come from 10 degrees Celsius to 0 degrees Celsius ice. So Q absorbed by ice, we have already calculated, it would be 20 into half into 10, so it is 200, in fact 100, and Q released by the water would be equal to 10 into 1 into 1 plus 1 into 80, so this is 90 calorie. So what you can see that if water completely freezes into ice, then also it can only give 90 calorie, but ice requires 100 calorie of heat to come to 0 degrees Celsius, which clearly means that ice would not come to 0 degrees Celsius and water will freeze completely. Therefore, ice will not come to 0 degrees Celsius and water freezes completely. And if water freezes completely, then composition of ice would be equal to 10 plus 1 gram, and composition of water would be 0 grams. And now we know that the final temperature would be, let's suppose, minus T degrees Celsius, because the final temperature would be negative. So let us see that ice has came from minus 10 degrees Celsius to minus T degrees Celsius, and water came from 10 degrees Celsius water to minus T degrees Celsius. So now in this case the Q absorbed by the ice would be 10 into the mass of the ice was I think 20 gram, yes. So this is 20 into the change in temperature. We have to write only the magnitude of the change in temperature. So if the change in temperature is T final minus T initial, then it would be 10 minus T. So we are just writing the magnitude, so it is 10 minus T, and the amount of heat released by the water would be 90, which it has released in the process of conversion from 10 degrees Celsius to 0 degrees Celsius ice completely, plus that water which has freezed completely would also move from 0 degrees Celsius to minus T degrees Celsius. So in that case, the mass of water was 1, S is half, and the temperature change is T. We have to only write down the magnitude mod of the change in temperature. So this is equal to, you can see that this is half, in fact. Mass of ice is 20 and specific heat is half. So this is 100 minus 10T is equal to 90 plus T by 2. So 10 is equal to 10T plus T by 2. So you can see that it is equal to 21T by 2. So T will be equal to 20 by 21 T mod. So we can say that T final will be equal to minus of 20 by 21 degree Celsius, which is approximately 1 degree, minus 1 degree Celsius around. So this would be the final temperature of the mixture, and final composition I have already written in this case. So I hope you have a clear understanding about the ice water mixture problems, and many students are having this query that we have never seen the complete water freezing when we mix ice and water. So this is due to the fact that in practical scenario, when we mix ice and water, then there is a heat exchange with the third body also, which is the surrounding. So when obviously we know that the surrounding temperature is the room temperature, which would be greater than the temperature of ice, obviously. So finally ice cannot be formed because the room temperature is 27 degrees Celsius around. So water would be formed at any case. But in this case, when we are solving these problems, we are assuming that this mixture is in the isolated system, and in a isolated system there is no heat exchange with the third one. So any heat is exchanged only between these two, and in this case complete ice can also be formed. Okay, so in the next video I'll be bringing these concept illustration problems, which are the mix problems, level 1 problems, and you would be getting more types of problems from calorimetry. Thank you.